Hi guys, Krishant here. Today we are going to see about the chapter motion. It is a little bit big chapter, so I divided this chapter into two videos. It is the first video of it. So let's get started. Difference between motion and movement. If I say someone, what is the difference between motion and movement? They will say there is no difference. It is the same word, but according to physics there is a difference. Motion is the phenomena of change in position of the whole body with respect to time and point of reference. But movement is the phenomenon of change in position of the part of the body with respect to time and point of reference. Our last definition introduced us a new word called point of reference. Point of reference refers to a person who is seeing the motion. For example, think you are outside the train and your friend is inside the train which is moving. Your friend will think that he is at rest, but you will think him that he is at motion. So both of them are correct. So while you are saying about a motion, you should say from whose point of reference. We all have read about distance and displacement from our 6th standard, so I am not going to teach that much about it. Distance is the length of the actual path traveled by the body. It is a scalar quantity, which means it has only magnitude but no direction. Displacement is the shortest path between 2 points. It is a vector quantity, which means they have both magnitude and direction. Difference between distance and displacement. Think that this box is your car and you have to go to school, which is right there, by picking up your friend whose house is here. So you are moving by this way. But the displacement between the school and car is only 30 meter, but distance traveled is 50 meter because of picking up your friend. Speed and velocity. Speed is the value of distance travelled per unit time. It is a scalar quantity and its formula is distance by time. Average speed is equal to total distance by total time. If the speed increases and decreases, you can use this formula. Velocity. It is the value of displacement per unit time. It is a vector quantity. Its formula is displacement by time. Average velocity in uniform acceleration is v plus u by 2. Average velocity is equal to total displacement by total time. Now let us see the difference between speed and velocity. We can take the last example itself, but the time taken to go from starting point to the school is 10 seconds. So if you go like this, then distance is 50 meters and time is 10 seconds. So speed is 10 meter per second, but velocity is 30 by 10, which is 3 meter per second. Uniform speed and non-uniform speed. If a body travels equal distance in equal interval of time, then it is said to be in uniform motion. If a body does not travel equal distance in equal interval of time, it is said to be in non-uniform motion. Acceleration. The rate of change of velocity is called acceleration. It is a vector quantity, which means it has both magnitude and direction. Acceleration is equal to final velocity minus initial velocity by time, or we can put final velocity as v and initial velocity as u. It will come like v minus u by t. Equations of motion. There are three equations of motion. V is equal to u plus at, s is equal to ut plus half at square, and v square minus u square is equal to 2as. The first equation connects between time and velocity. Second connects between displacement and time. Third connects between velocity and displacement. Derivation of v is equal to u plus at. We know acceleration is equal to v minus u by t. If we take t to that side, then it will come at is equal to v minus u. If you take u to that side, it will come v is equal to u plus at. Hence derivation. Derivation of S is equal to ut plus half at square. V average is equal to V plus u by 2, we already know it, and V average is equal to displacement by time, we already know it. V is equal to u plus at, we derived it. Combined equation 1 and 2, we get S by T is equal to V plus u by 2. If you take T to the side, then it will come S is equal to Vt plus ut by 2. Combine equation 3 and equation 4, we get S is equal to u plus at into t plus ut by 2. If we derive most, then this S is equal to 2 ut by 2 plus at square by 2. 2 and 2 will get cancelled and it will come S is equal to ut plus half at square. Now let us finally derive the last equation, v square minus u square is equal to 2as. From v is equal to u plus at, we get t is equal to v minus u by a, and we know s is equal to ut plus half at square. If you substitute the value of t in the second equation, we get a value like this. Then if you simplify further, it will come v square minus u square is equal to 2a. Now let us see about different types of displacement time graph. First one is where the slope is parallel to the time axis. This is where the body is at rest because the displacement does not change with respect to time. The second one is where it is inclined to the time axis. This will come when there is a constant velocity. The slope of the displacement time graph is equal to velocity. The third one is the graph which look like this. It means the velocity is increasing as the slope is increasing. And the last one is where the graph look like this. It means the velocity is decreasing where because of the slope is decreasing. Now let us see various type of velocity time graph. First one is where the slope is parallel to the time axis. It means it has constant velocity. Second one is where it look like this. It means it has constant acceleration. The slope of this velocity time graph is equal to acceleration, and the area under velocity time graph is equal to displacement. The third one is where it look like this. It means the acceleration is increasing as the slope is increasing. Third one is when it looks like this, in which the acceleration is decreasing because of velocity is decreasing. To be continued. Wait for part 2 to be published, and if it is published, the link will be in the description. Thank you.